In this video, we talk about custom AOVs, global AOV shaders, and Cryptomatte. Let's start with custom AOVs. And there are a few different types of custom AOVs. The first one is through the object mask tag. Let's right click on this old alarm clock, and from the C4D2A tags, add an Arnold object mask tag. Object mask is exactly like object buffer multipass in Cinema 4D. In Cinema, if we want to create matte for an object to have greater control over that object, in compositing, we add a Cinema 4D compositing tag to that object and create an object buffer for it. Object mask works in a similar fashion. If I select the tag, right now we create an AOV that its name will be based on the object's name. The object name that this tag is applied to is old_clock, and the AOV type will be float, which we can change it to RGB or RGBA. If I go to the render settings and check the AOV tab, we should have a new custom AOV called old_clock in our active list. And if I run the IPR and take a look at that old clock AOV, it gives us a white matte or mask for that alarm clock. If I select the tag again, we can change the AOV type to RGB, for example, and create RGB masks instead of a simple white mask. If I rerun the IPR, I can choose R, G, or the B channel or a combination, which can be useful for masking in post. I can change the AOV name from object name to custom and name this AOV what I want. Let's try something simple like clock. Now, if I get back to the beauty pass and reopen the AOV tab in the render settings, we should have this clock AOV instead. We can take a look at that AOV in the IPR again. In the render settings under the AOV tab, we have this add custom AOV button. You saw that Arnold adds these custom AOVs automatically. In previous versions of Arnold, it was done manually. For example, I can remove this clock AOV from the active list. Now click on this add custom AOV. Now the name here should be copied from the AOV name that you have defined in the tag, which was clock. Change the data type to RGB as well, like the tag, and press OK. Now we have done the same thing but manually. We can check that AOV in the IPR again. But as it's done automatically, you don't have to go through these steps. So let's just remove this custom AOV. In the object tag, change the AOV name to object name, and we should have our old clock AOV automatically added to the active list. Let's get back to the beauty pass in the IPR. Now let's talk about Arnold custom AOV tag. Let's add one to this abstract object geometry from the C4D2A tags. Now, custom AOV tag allows you to render out different shading effects as a separate AOV. Let's say I have this pink SSS shader as the shader for this abstract object in my beauty pass, but I want a wireframe shader to be applied to this object in a separate AOV pass. First, we need to name the AOV. Let's name it something like wireframe. Now, if we check out the AOV tab in the render settings, we have this new wireframe AOV. Now the AOV type is RGB, which is what we want. Now we need to create that wireframe shader and assign it to this material field here. So create a new wireframe shader from the material manager and use it as the material for the custom AOV tag. Now we can take a look at that wireframe AOV in the IPR. And here is our wireframe shader. Cool. Now, if we wanted to expand this wireframe shader to the books geometry, for example, I can simply control drag this tag on that geometry. And if we rerun the IPR, now this wireframe pass contains the books geometry as well. I can have multiple custom AOV tags per object. So if you wanted to render out like a normal AOV for the abstract object, I can add a new custom AOV tag, name the AOV normal, add a new utility shader in the material manager, change the shade mode to flat and color mode to normal. Now add this new shader to the material field of that new custom AOV tag. And we should have that new normal AOV pass for the abstract object as well. You can add custom AOVs through the AOV write nodes as well, which are basically per shader custom AOVs, which is a bit harder. In the material manager, this is the shader that is assigned to the abstract object geometry. Middle click on it to open up its network. Add the utility shader and set it as the beauty shader. Change the shade mode to flat and color mode to uniform ID, for example. Now we want to keep that pink SSS material as the beauty shader, but add this uniform ID pass as an extra AOV. For that, we can use an AOV write RGB node. So add one from the AOV shaders and set it as the beauty shader. AOV write nodes can be used to write out different custom passes or AOVs from your shading network. This node has a pass-through input and we need to connect our main beauty shader to this input. So connect the pink standard surface shader to the pass-through input and now it shows up in the render. We need to connect the shader we want to show up in that AOV to this AOV input. In this case, we will connect the utility shader and now we need to name this AOV. Let's name it something like uniform ID. Now, if you take a look at the AOV tab in the render settings, we get this uniform ID pass, which should be available in the IPR as well. Now, if I get back to the shader network again, let's duplicate the utility shader and set it as the beauty shader, this new node, and change the color mode to shading point this time. Now, how can we add this shading point shader as another AOV? So to do this, add a new AOV write RGB node. Name the AOV shading point. Obviously, the name can be anything, but we're using something recognizable. The pass-through or the beauty shader is going to be the previous AOV write RGB node. The AOV input is our new utility shader. And now connect the new AOV write RGB node to the beauty pass. Now we should have both our uniform ID AOV and our shading point AOV. Cool. So this way we can chain up as many AOV write nodes as we want, but a simpler way exists, and that is called pass-through node. So let's add a pass-through node. Pass-through evaluates any shading network connected to the evaluation's 1 to 20 inputs. The pass-through input is evaluated first and is passed as is to the output. This shader is useful to force the evaluation of parallel shading networks that are not part of the beauty pass, whose resulting value you need to store in an AOV, for example. In this case, the pass-through node will be connected to the beauty port. Our pink standard surface shader will be connected as its pass-through input. And we need to disconnect the standard surface shader from the AOV write RGB pass-through input, and also disconnect the first AOV write node from the second one. Now connect the first AOV write node to evaluation 1 input of the pass-through node and connect the second AOV write node to evaluation 2 input. Now we should get our uniform ID and shading point AOVs, and we can add as many more AOV write nodes as we want, up to 20. Now let me close the shader network and get back to the beauty pass. Next, I want to talk about global AOV shaders. Let's say we want to add a wireframe shader or an ambient occlusion shader or whatever, not to one geometry or shader, but to the entire scene. That's where global AOV shaders can help us. If you go to the main tab in the render settings and come down to the advanced section, here we have this AOV shaders or global AOV shaders list. So any shader you assign here through an AOV write node node will be applied to the entire scene. Let's say we want to add a wireframe shader to the entire scene as a separate AOV. So create a new shader network. Add a wireframe shader and change its edge type to polygons. Now add an AOV right RGB node and set it as the beauty shader. Let's name this AOV wireframe_global. And connect the wireframe shader to the AOV input. Now we can close the shader network. Let's rename the shader network to something less generic, maybe WF_global. Now we simply add this WF_global shader to our global AOV shaders list. Now, if I check out the AOVs tab, we should have this wireframe_global custom AOV. And if we check it out in the IPR, we should see that the wireframe shader is applied to the entire scene. You can add as many global shaders as you want like this. One of the most important global AOV shaders that you need to use in any render that is intended to post work in a compositing app is Cryptomatte. I'm pretty sure you have heard of the Cryptomatte shader. Cryptomatte creates ID mattes automatically with support for motion blur, transparency, and depth of field. Let's see how to set it up manually. There is a much easier way to do it, which I will show you in a few moments, but for now, let's do it manually. So first, let's create a new Arnold shader network. Add a Cryptomatte shader to the work area and set it as the beauty shader. In case of Cryptomatte, we don't need an AOV right node. Let's rename the shader network itself to something recognizable like Cryptomatte_global or something, or just Cryptomatte. Now we can close the shader network and add this Cryptomatte shader to our global AOV shaders list. Now in the AOV tab of the render settings, if we search for Cryptomatte in the inactive AOVs, we find 3 Cryptomatte AOVs: asset, material, and object. Add all of them to the active list. Now if we run the IPR, we should get these 3 Cryptomatte AOVs and have all of these automatic IDs created for us without having to go through setting them up manually using object mask or custom AOV tag. Cryptomatte can be incredibly useful in compositing as it gives you all of these different ID mats for free, and you can have precise selections in post, which I'll be showing you for sure in the compositing in Fusion video. If you go to the Arnold menu under utility submenu, you have this setup Cryptomatte button, which goes through what we did automatically. Just click here and it will set it up, which is fantastic. You can check that out on your own. So the Cryptomatte shader itself has tons of settings, which I'm not gonna go through in this video, but you can check out Arnold user guide page on arnoldrenderer.com. One quick last thing I want to talk about is the standard surface and standard hair ID AOVs. Let's open up this blue velvet shader and come down to the ID section of the standard surface shader. We discussed this in the shading section of the course, but let's recap here. So these IDs here allow you to create up to 8 shader-based mattes for any shader. Let's say we want to create a blue matte for any geometry that has this velvet shader, or it can be a white matte or anything. So let's change the ID one color to blue in this case. Now in the render settings, add the standard surface ID1 to the active list. And now we can check this ID1 AOV in the IPR, which should be a blue matte for the velvet shader. And the same thing can be done for standard hair shader. I think we're good. So in this video, we learned about custom AOVs, global AOV shaders, Cryptomatte, and so many other things. See you in the next video.